Now let's talk about even and odd functions. Both even and odd functions display symmetry, but the type of symmetry they display is different. For an even function, this one here on the left, we see symmetry across the y-axis. So if I took my graph and I flipped it across the y-axis, you would never know. Let's flip it back. To identify even functions, if a function is a polynomial, I can tell that we're dealing with an even function if all the exponents in my polynomial are even exponents. This is the case here because we can think of 1 as 1 times x to the 0, because x to the 0 is 1. And that gives me exponents of 4, 2, and 0, all even. For odd functions, the type of symmetry we see is rotational symmetry, or symmetry around the origin. So if I take my graph and I rotate it 180 degrees, you'd never know. Now, again, if we're dealing with a polynomial, if all my exponents are odd, I can identify the function as an odd function. So what does that mean as far as the equation itself? How could we test to see if a function is even or odd? Well, if we go back to the image, we can see that for every positive value of x that generates a y value, I get that same y value for the negative value of x. And that's what this expression says. F of 3 gives me the same value of f of negative 3. For an odd function, to transform between one side of the graph and the other by rotating, every xy coordinate on my original graph has a corresponding value at negative x and negative y. So for example, if this point happened to be 1, 5, I would find my new point by multiplying the x by negative 1, and this new point would be negative 1, negative 5, because I would multiply the y value by negative 1 as well. So in general terms, we'd have this equation. I would take every x and y to start with, and I could find a corresponding value by multiplying the x and y both by negative 1. Another way to write that relationship would be this, because I could just move that negative sign over to the left and the relationship would still be true. Note that for odd functions, reflection across the y-axis gives the same image as reflection across the x-axis. So if I took my odd function and flipped it across the y-axis, I'd get the same thing as if I flipped it across the x-axis. For even functions, as we discussed, if I reflect across the y-axis, you'd never know. There are only particular functions that have either an even or an odd property. Most of our functions that we'll be dealing with are neither even or odd.